The skin itself is a barrier to the external world. You need to be able to respond to things like physical trauma, to pathogens, and so it has a remarkable ability to both generate and resolve these kind of inflammatory contexts. But in the setting of autoimmunity, you're no longer able to turn off that switch. At a fundamental level, the body is confused in recognizing something as a virus. I focus on cutaneous lupus. Lupus itself mimics in some ways a viral infection. The signals that we see in these patients are elevated interferons, and that's a molecule that is important for fighting off viruses. And that's why lupus patients, they may say they have chronic fatigue, they feel terrible. Well, they quite literally are feeling the effects of a viral infection because at the molecular level, there are considerable similarities. One of the major things that we study is something called retroelements. So these have integrated into our genome over many millions of years. And they comprise actually about 50% of our genome. Normally, these elements are epigenetically silent, so you don't really see them in normal tissues, but in the setting of autoimmunity, they do become transcriptionally active. We believe the body is recognizing some of these retroelements in a capacity that it thinks it's a virus. We do use cutting-edge technologies like single-cell RNA sequencing, spatial single-cell RNA sequencing, and that's really able to kind of map the disease architecture at the cellular level. So you're able to get very high-resolution information from that. Additionally, we take samples from patients and we move that into an in vitro setting, and we're able to deliver specific controlled interventions to try to discern like cause and effect molecular mechanisms. And additionally, we do use genetically engineered models that recapitulate certain aspects of human disease. And again, in that more controlled environment, we're able to test specific interventions and see their effect. Ultimately, one of the major goals is to better understand the source of both the innate and adaptive immune signals that manifest as autoimmunity in lupus patients. If we're able to better target things upstream and prevent that process from happening, perhaps we're better able to get precise targeted therapies that have less side effects for patients.